Aim of our research work is to design compact 4-port MIMO antenna duplexer utilizing slotted half-mode SAW technology. Our presentation will cover the following sections. Introduction. Multi-band antennas are widely used in compact mobile wireless systems. In traditional systems, a duplexer is used to separate transmitting and receiving signals. However, self-diplexing antennas can naturally perform this function without extra components. This makes the system simpler, more compact and efficient. Increasing the channel capacity improves the wireless coverage and ensures a strong reliable connection. To address these challenges, this work presents a novel compact 2x2 MIMO self-diplexing antenna based on half-mode substrate integrated waveguide technology. Figure 1 shows the proposed 4-port 2x2 MIMO antenna duplexer yielding at two different frequencies. This antenna is fabricated on Rogers RT-Durad 580 substrate with a thickness of 1.575 mm. Equation 1 and 2 are used to calculate the frequencies of MIMO antenna. A full mode Initially, a full mode SAW cavity is excited via coaxial feed to achieve the dominant mode at 5.2 GHz. When port 1 and port 2 are excited, two off-mode SAW cavities resonate at 4.9 GHz and 5.8 GHz. Bandwidth enhancement is achieved by placing the rectangular slot at the center of the cavity. When port 1 is excited, the TE110 mode splits into half TE110 mode resonated 4.85 GHz and another half TE110 mode resonated 5 GHz. When port 2 is excited, odd even modes of cavity 2 resonated 5.7 GHz and 5.85 GHz. Figure 3 represents the S-parameter responses for the design evolution from full mode SAW cavity. By positioning the two cavities orthogonally, high isolation is achieved, that is greater than 45 dB. Slot insertion enhances the bandwidth but reduces the isolation by approximately 8 dB. To ensure a high decoupling, frequency selective radiating elements are placed orthogonally, sharing electric walls. This setup suppresses the same frequency fields, causing dips in S13 and S24 at operating frequencies. Figure 5 shows the S parameters versus frequency with the length of the slot is varied, increasing the LS1 or LS2 leading to a downward shift in frequency and affecting the impedance matching across both the frequency bands. Figure 6 shows the S parameters versus frequency with the slot position varied. The slot position influences the mode coupling in both the lower and upper frequency bands, making it is a critical factor for optimal impedance matching. Figure 7 shows the S parameters versus frequency varying the gap between the cavities and the size of the cavity. If we increase the gap between the cavities, it alters the mode coupling, leading to an enhanced bandwidth across the upper and lower frequency bands. If we increase the size of the cavity, it results in downward frequency shift due to an enlarged effective aperture. The proposed antenna achieves the ECC is less than 0.05 and diversity gain is less than 9.8 dB in both the frequency bands. The proposed antenna maintains the TARC is less than -12 dB and it also maintains the CCL is less than 0.1 bits per second for hedges across both the frequency bands. Figure 10 shows the photographs of fabricated phototype, front view, bottom view, simulated results and radiation patterns. This antenna exhibits a stable bandwidth and gain performance. When port 1 is excited, the measured bandwidth is 150 MHz. For port 2, the bandwidth is 250 MHz. The measured gain ranges from 4.8 to 5.2 dBA in lower band and 5.59 to 5.86 dBA in upper frequency bands. The radiation pattern shows the front to back ratio exceeding 10 dB in both the bands. The copole to cross polarization ratio is greater than 17 dB in visor plane and 11 dB in the exit plane. Conclusion. This article presents a compact 4-port self-diplexing MIMO antenna designed for wireless LAN and ISM band applications. By utilizing the nature of TE110 mode and half-mode SAW techniques, this design achieves a 50% size reduction. Radiating elements positioned out of the phase effectively cancel the field coupling, resulting in isolation exceeding 30 dB between any two ports. MIMO performance metrics ECC, MEG, CCL, and TARC are found in satisfactory limits. The proposed antenna features a simple low-profile configuration with self-diplexing capabilities, offering dual-channel capacity in both the frequency bands. It's a compact design, reliable communication, and superior radiation properties make it ideal for dense wireless communication networks. Thank you.